In this video, we're going to use the quadratic formula to solve quadratic equations. So when we're solving quadratic equations, either with the quadratic formula or with factoring, an important thing is that we have to have 0 on one side of the equation. If we don't have 0 on one side, then we need to get 0 on one side by moving pieces over. And again, that's true whether we're using the quadratic formula or using factoring. So when I look at this x squared plus 5x plus 3, I know that that cannot be factored because there are not two numbers that multiply to 3 and add to 5. It has to be 3 times 1, and that's always going to equal 4. It can't be 5. So this is why I need to use the quadratic formula. So when I'm using the quadratic formula, my first step is to identify a, b, and c. A is the number in front of x squared. So in this case, that's going to be 1. B is the number in front of x, so in this case that's going to be 5, and c is the number that's by itself, so that's going to be 3. Once I've identified a, b, and c, I'm going to plug them into the quadratic formula, which is written out here. So what I'm going to plug in first is b. Negative b is going to be minus 5. Then I have a plus minus, the square root of, and then b squared. So b is 5 again. Minus 4 times a times c. A is going to be 1, and c is going to be 3. And that's all divided by 2a. So plug in 1 again for a. Now we're going to simplify this. So when I'm simplifying, I'm going to start by attaching this negative sign to b, so negative 5. And then we have plus minus. Then I'm going to simplify what's under the square root. I know that 5 squared is 25, and 4 times 1 times 3 is going to be 12. So 25 minus 12 under the square root. And then that's divided by 2 times 1, which is 2. Next, I'm going to continue simplifying under the square root, and I know that 25 minus 12 is 13. So that's the square root of 13. Now once I get to this point, I'm going to look at the square root and determine what I can do next. If this were a perfect square, so say that it were 16 under the square root, well, I know square root of 16 is 4. So I can take the square root and I can continue to simplify. If it is something that can be simplified, then I would do that. So remember from previously that to simplify square roots, I see if there are any perfect square factors that it can be divided by. 13 cannot be divided by 9 or 4 evenly, so that means that it cannot be simplified. So in that case, there's nothing left to do, so I'm just going to leave my answer like this. You can enter it into the homework using the plus or minus symbol, which you should see at the bottom of the window. You can also enter it in as two separate fractions. I usually use the plus or minus symbol just because it's a little bit less to type. But if you want to enter it as two separate fractions, it would look like this. Negative 5 plus square root of 13 over 2, and negative 5 minus square root of 13 over 2. So essentially, what you're doing is you are breaking up the plus or minus here into two separate numbers. And so just like with factoring, we oftentimes get two solutions when we're using the quadratic formula. So now what we're going to do is look at this on the decimals graphing calculator. So just like we did previously, we are going to graph y equals, replacing that 0 in our quadratic equation with a y. Y equals x squared plus 5x plus 3. And the question is, what do you notice about the x-intercepts of the graph? So here's my graph, and I clicked on my x-intercepts to show what they are. So as you can see, the x-intercepts are decimal numbers that have several digits after the decimal point. And this happens because I have a square root that's not a perfect square in my answer. So these decimal numbers will not work if you try to enter them into the MyLab homework system. They will not be marked correct. You have to enter it in what's called the exact answer that has the square root symbol in it. So these x-intercepts are decimals, with several digits after the decimal point. They are what's called irrational numbers, which means that there are infinitely many digits after the decimal point, but Desmos is obviously going to cut that off at some point and round it, but technically this would keep on going forever. And again, that's because of the square root. So we're going to do another example here. This one is x squared minus 6x plus 10. So again, we're going to identify a, b, and c. A is 1, b is negative 6, and c is positive 10. Then we will plug in. So we're plugging in negative 6 for b. We are plugging in 1 for a, and we're plugging in 10 for c. So now let's simplify. One thing that we want to be careful of is this minus negative 6 here. That's going to change to positive 6. Another thing that we want to be careful of is squaring this negative 6. Negative 6 times negative 6 is positive 36. If you're doing it on a calculator, you need to make sure that you're typing it in parentheses, the way that I have it written here. If you just type it in like this, minus 6 squared, it's going to square the 6 and then make it negative, which is not what you're trying to do. You're trying to do negative 6 times negative 6. We have 4 times 1 times 10, which is 40, and then it's divided by 2 times 1, which is 2. So simplifying what's under the square root, 36 minus 40 is negative 4. So, looking at the square root, well, I see that 4 is a perfect square. I also see that it's negative 4. So remember from a few weeks ago, square root of negative 4 is positive 2i. The negative sign becomes the I, and 4 is a perfect square, so I take the square root and get 2. So we have 6 plus or minus 2i over 2. Now I can continue with one last step here to simplify, which is that I can break this up into two separate fractions. 6 over 2 and 2i over 2. So I'm just writing each part of the numerator over the denominator separately, which is 2. So 6 divided by 2, that's 3. And then we have the plus or minus 2i over 2. The 2's are going to cancel out, and that's just I. We treat I just like any other variable here. We can't combine it with the 6 because they aren't like terms. Just like I can't add 2x plus 6, I can't add 2i plus 6. So this is how I can simplify it, is by putting each part over the denominator and then simplifying as I can. So I could write this way with the plus or minus symbol. I could also again write it as two separate numbers, 3 plus I, comma, 3 minus I. Either way is fine. Now, lastly, we're going to look at this on the graphing calculator. So I have it here. I'm going to turn the red off and turn that one on and move it over here so that we can see it. So what do you notice about this? Well, remember from earlier that when we are looking at these solutions, they are the x-intercepts of the parabola. But there are no x-intercepts for this parabola. So that's how we get the imaginary solutions. If there are no x-intercepts in the parabola, then that means that our solutions are not real numbers, they are imaginary, or they have I terms.